Morning, guys. Power there. 20 watts, 3 amps. Might need that, not sure. Game Boy. Let's build first. Morning. We've got an exciting little samples box here. We'll get onto in a second. It's a ton of new products. I've got to quickly test a few to get them out for orders. So I'm just doing orders this morning, so this will just be a quick stream, but I want to look at some of these samples. Let's see if we can confirm if they work or not. I've just got to build, obviously, a few more Game Gear populated, so just finishing these off while the stream all settles in and goes live everywhere. So a little bit of a rush this morning, but I just wanted to show off the samples now they've been delivered, and we'll see if they work or not. Usually the samples don't always work first time, but I'm hoping these ones do. They should fit through. Those legs are a little bent, that's why. What's everybody up to this morning? Anyone as daft as me to work on a Sunday, or are we doing non-work stuff? There we go. Don't think I've turned on the overhead camera actually. That should come on now. There we go. So for those of you just joining, we're not building. Well, technically I'm building more re-PCBs at the minute, but this is just quickly while the stream sets up, and then we have a box of samples. So brand new products I've invented that we haven't tested yet. Well, some are just a new factory making the same products, but there's a few brand new products in there I need to test. So I'll jump onto that in a second as soon as I've just finished off these connectors on these re-PCBs. It's not just me working then on a Sunday. I think it's more peaceful though, because there's no workers around to distract you, and you haven't got a time limit. You can just work until you feel like and then knock off. That's 2 of them, I believe. I think I've got to put connectors on that one actually. So I'll just I'll give you a sneak peek of what's to come. So we have a nice goodie box here. zoomed really far in. Let's zoom out a bit. Let's take a look at what we've got. So we have, this is the Sega Saturn Clean Power. This is a new version, so the Dreamcast Clean Power's already had this version, so really these should work. This is a direct, exact same design as the Dreamcast, basically, but we did already have samples made and they didn't work, and that was because the main controller chip turned out to be fake. So the factory had purchased stock. The main, I think, DigiKey was out of stock. Where they sourced them from, they were fake, so they didn't work under load, because these are meant to work under really heavy load, and they didn't because they were fake. So we've got 3 different versions here to test from 3 different suppliers, and I'll stress test them to make sure they work, but hopefully they won't be too much of a problem. What else have we got? We've got the Atari Clean Comps. I'll probably have to jump back on a stream later to test these, because like I say, I'm in a bit of a rush. I'm in the middle of packing orders. The main thing I need to test is these work, because they're on an order. But these are not a redesign anyway. These are just the clean comp, so I'll probably just show this off and make a kind of an install video, I guess, at the same time. Oh yes, these are the fun ones. So these are GBA CleanJuice. So at the minute, we've got a Game Boy line around here somewhere. Got one here. Of course, it hasn't got one in. We offer the CleanJuice that goes in the back of here with a USB coming out, and it's basically a custom LiPo battery, which is no problem, but then for shipping and for production, we have to make batteries, and the shipping costs a lot. So the idea with this is I've made a CleanJuice AA. So this is a brand new product, we haven't tested it yet. We're hoping this fits. It's a really tight design, but I'm hoping it fits in here. So you put AAs in like rechargeables, and then you basically put these in here as the goal. Put the batteries in, bend down, get them in, and basically the idea is if it works and I've designed it right and the shape's right, this will just about fit in that compartment, and then we can have a rechargeable USB that just recharges AAs. This will be much cheaper then than the other CleanJuice, and you're not stuck with custom LiPos that we produce. This can be shipped worldwide then as well as a letter. So just so many benefits to doing the CleanJuice this way. So that one I'm really excited about. That was quite a technical challenge. I've had to have a custom USB made as well. So this is literally, again, been made for us. So see how long the USB is, and the fact there's only one mounting point and no pins on the side. So this is, again, a completely custom port. We've had to have thousands made. So hopefully that's going to work. We've got then the ports to test separately. Some new connectors, so you can ignore those. And these little things are, they are what they think they are. Yeah, these are the Pico, can't remember what I called them. I think I called them Pico Power or something. So the Retro Core Pico. So this is just a baby power supply. And all it does is, I've designed it for, again, the GBA Clean Light. Because the 5-volt rail on the GBA collapses under load, so when we've got the new clean light in, it's causing the GBA to reset, so I'm having to make this to fix that. But ultimately you put ground in, any voltage from, I think I've spec'd it to 1.2 volts. I think you can put as low as 1.2 volts in and up to 5.5, so basically 2 AAs will work perfect, and it'll output a stable 5 volt up to 3 amp. And there's the actual IC. Let's zoom right in on this so you can appreciate how small this is. Zoom right in, zoom even more, and there you go. So where's tweezers? That is a 3 amp boost buck regulator, so we can put in up to 3 amps out. We've got filtering on this as well, so it's not just a regulator, we should have audio filtering built in. So it's basically just ground, a low input, and you'll get a stable 5 volt out. And if you want to change the voltage, you can change these resistors to get a variable voltage. So it's a bit more of a universal board. So I made it as small as possible and then just called it the Retro Core Pico. So this is just, at the minute, will come with the clean light for the GBA, but ultimately it's also, I could release it as a universal baby filtered power supply. So this will be good for like video noise and any retro circuit really that wants a stable 5 volts. This can be used for that. So we'll probably get to them separately. I want to finish building these two up, and then we'll test these. This is the main thing I need to quickly test, is the Sega Saturn Clean Powers. I'm glad you're liking the custom GBAs. You might want to get the Clean Light and the new CleanJuice when they come out as well, unless you've already got like the CleanJuice with the lipos. We've got crystalline connector, just needs this. We've got a ton of viewers on YouTube this morning. That's more than we've ever had. Maybe it's a Sunday morning stream. Temps on the 3 volt, 3 amp, that's what we'll find out. I'll probably jump on later today and we'll stress test that. Obviously, the chip is designed for 3 amp, which means it will be capable, but we'll obviously have to, if you want to push it to 3 amps, we're going to have to look at thermals. So probably heatsink, or might even need passive active cooling. The Game Boy is designed for, it only needs about half an amp, even when it's fully loaded. So we'll stress test it to the expected voltage, which is the half an amp, and then we'll also test it with its max load. I think it's technically it's 1.5 amps unless the input voltage is above, I think, 2 volts. So we'll check the data sheet on that. But basically, if the input voltage drops too low, you can only output 1.5 amps. But if the input voltage is high enough, which is pretty much so long as, like, say, 2 AA batteries aren't completely flat, then we can get the full 3 amps. But yeah, thermals are 100% going to need to be taken into account. But all regulators and all designs work different. So until we test it, we won't know. Right, that's 2 of them. I've got 1 more to do with... Oh, put that in there. This cable. And then we'll get on to the exciting stuff. So this connector is needing cleaning. I've just started watching a new thing as well on, I think it's on Netflix. The $1 million something. I can't think what it's called. They like go in a mansion, and one person gets $1 million in a box, and they have to hide the fact they've got it. And like as a team, they meant to be working out to find out who has got the money. It was really good. Only watched 2 episodes, but I don't know whether any of you guys have seen that or what it's called. I'm sure it's $1 million something. I just can't think of the last word of it. This tip is definitely on its way out. The only problem with these connectors, they're a pain to, if the little pins aren't perfectly straight, getting them through the connector is a bit of a pain. There we go. Oh, this isn't it. This is well late for me. I've been out for a nice early coffee, about 7, 8ish, and then been packing some orders because we've had the new power core for the Game Gear Land and the Duo were on back order, so we've got tons of orders that are backlogged that we want to try and clear off before tomorrow. And then this is just, we're just quickly doing these Game Gears. This is the last one. And then I'm on to testing some prototypes. You might want to stick around to see that be tested in a minute. It's only going to be a quick stream, probably half an hour, just to test the Sega Saturn Clean Powers. Then I can go finish off orders and I might jump back on later to show off all the other prototype stuff. The bin is just full of Game Gears. Just all the leftover Game Gear parts. Yeah, I'll still be doing videos. It's just given time. The live streams I don't have to think about them. I just jump on live and go for it. So I still plan to do some. I'll probably just mix and match all the video styles because people like all of them. Some people like the classic TikTok vertical style. Others like the pre-recorded YouTube long format. But to be honest, the lives, I'm getting more views than most other platform, and I don't have to, like I say, don't have to think about anything or plan anything. I just jump on and do what I'd be doing if the camera wasn't running. So these are easy to just quickly jump on, and people can see what we're doing. But then the pre-recorded videos, they take a lot of time to, I know some of them are only a few minute videos, and the other ones, but they take time to think about, get the camera angles, edit them after, write the images, do the screenshots, upload. There's a lot more work in that than the live streams. These are so easy, and like I say, I think, to be honest, people seem to be enjoying these a lot. Just being able to join in and see what we're doing, and it gives me somebody to talk to instead of sitting in silence while I work. So it kind of works both ways. So that is all done. So is that one. So is that one. So there's the 3 populated I needed. Let's get them out of the way. And now let's just clean up this desk and get on to the fun stuff. Oh, Rusty was fast asleep, so I'm going to take him out later. He was awake until 5 minutes before we left, and he just passed out. He got up early with us and then just completely fell asleep. So I think he's even... yeah, he's sleeping at the minute. But we'll wake him up and go for another drink later, definitely. Too lazy to get the Hoover out. There we go, cleaning off. Right, on to the fun stuff. So we've got the Atari Clean Comps. So let's just go over here maybe. These are existing products. They basically give the Atari 2600 the cleanest video output on composite of any mod. And it's now been quite stable. We've sold about, I think this is the 3rd production, so either if I've done 500 at a time, this will be like the 1000th board to sell. And then we have, these are brand new. I'm excited about these, but I don't want to rush. Actually, no, let's do these first. Yeah, let's do these first. I'm just thinking of time. So the goal with this is we have the GBA here. Let me see if I've got one with a CleanJuice in already. Yeah, I do. So we've got this prototype, which is for a stream. It's got Dusty sitting there, just surface dust. This is for a streamer, so this is a custom one. this is the clean light. So this is actually the reason for, going off topic again, this is the reason for this Pico power supply, because I've managed to get this one works. I've installed a clean power inside, but if you put the LEDs up full brightness, use a flash cart, and set the clean screen to full brightness, this thing can power cycle. You can also hear a slight hum, so just a slight bit of noise, if you put max brightness on and have the flash cart. So ignoring that, that's what the Pico's for. This is the existing product, a CleanJuice. So it's a custom LiPo that you install. You push these springs down the side, and this is what people say, oh, it pops up. You just have to get it just right and it'll stop. And then the cover goes over, and what you can do is install it first, like you kind of wriggle that in so the USB fits. Doesn't look like it's very aligned on camera, but that's perfectly centered. It just doesn't look it on camera for some reason there. And now what you have is a USB-C rechargeable battery pack. So you can plug in, it lights up, and when it's charged, one of the two lights will go off. So there's two lights on this. Let's see what they are. You can see it says PG and charge. So PG stands for power good, and it means that this cable is providing power. So that light will always be on the green, and the bright blue one is the charge. So basically when the battery's fully charged, the blue goes out and you're left with a little green. But what I want to do is replace this option here, so we don't have to have them custom LiPos. Let's get that back in. And we also, in between changing factories, the USB port slightly changed, so they're a little bit more difficult to get in at the minute than they used to be. So we'll fix that. But I'm thinking of replacing it completely with this. So the idea with this now is, instead of having a custom LiPo, we can get rechargeables, and this is also kind of all links together, all the products in one. These are not the best at running on rechargeable batteries, so this Pico could be used inside to boost the voltage as well. I could integrate it onto this, but we'll see. Yeah, this is rechargeable. So rechargeable batteries are slightly less voltage. Oh, that's Rusty crying. 1 second, let me go grab him. Oh, cry, baby. Thank you. I'm trying to do a live stream. Right, you sit down here. And don't cry and scratch. Of course, that's all you're going to do now, isn't it? You're standing on all the games. What was I doing? Yeah, so these batteries are slightly less voltage than normal AAs. So if we get them up, and you measure, and basically 1.3 is almost fully charged. So a normal AA, if we get like whether these Kodaks are going to be fully charged is another matter. See, 1.5, 1.6. So two of them gives you 3 volts, and when they're fully discharged, you still get about 2.6. Whereas these fully charged are like 1.3. So you're going to get 2.6. You're going to get almost a flat voltage when they're fully charged on rechargeable. So there's a slight issue there that we might have to deal with, but I can tackle that as we go. The first step is to get this installed. So if we look over the top, the idea with this will be, we place, I haven't done this yet, but in my head when I've worked it out, we'll place this in place here, and we'll put one battery in and just rest him like that. And the other one goes the other way, like that. So now it's kind of floating in there. And if this works well, we kind of want to push these onto the batteries, like probably pre-fold them over, maybe bend them over, and maybe lift up a bit on the batteries, hold that one in. And I'm sure with either a bit of practice or thought, we'll be able to get this something like achievable. It's a little bit tricky at the minute, I think, but obviously first time doing it, so I think if we can find a way where this works, we might be able to just put the batteries in as well, to be honest, and just push down. And that's the other thing. Could we just put the battery in? Oh yeah, you can just actually put the battery in and kind of slide. Oh yeah, that's actually way easier. So you can almost just put the batteries in and slide these tabs through. But I'll play with trying to install that first. And now you'll see, this is why I've had to have a custom USB port made. It's also part of the design. See how that, zoom in a little bit. See how close that USB port is? That is literally by design. So it touches, just rests on the AA battery. And the reason for that will be, when this cover goes on, bring that into focus, this should poke clean through the USB hole. Yes, look at that. So it comes clean through and can move. Now we can lock it in position. Oh, actually, before I do that, these might have moved. These little plastic bars, metal tabs rather. We have on here these little dots. Hey, welcome from Russia. Thanks for joining in. We're just testing a few prototypes. This is a GBA rechargeable AAs, as it says here, so we can do away with custom lipos. We have, let me just zoom out. Oh, I am zoomed out, I'm zoomed right in. Okay, let's go to this one. Let's get this up. So the 3 dots you saw on the battery pack. So these 3 dots, we have ground is here, and then the first battery is here, and the second battery is here. So this is a way to quickly test if we have charge. So actually, this is a better angle if I just zoom out, so you can see it all. There we go. Well, I'll zoom out even more, so you can just about see there. So if we tap on the ground pad here and go to here, you can see there's the battery. So that's the first battery. We know it's connected well. This is the second battery in series, so we've got 2.6. So that's how we test. We've installed this well, and it's made good contact. Where can you get hands on one? This at the minute, this is the first prototype, so very first one. So I have 3 here, which I'll probably use myself and stress test and things before it goes into production. So that's now installed well, we know that. This can now hopefully slide through the port like it does. Oh yes, look at that. And now the point of this was, I'm going to zoom back in again. This is why I want that ob spot camera, so I don't have to keep lifting up and down and setting focus. The point of having this port made, this custom port, so here, and this genuinely is something I've had made. It's not like, you know, you won't find this USB port on the shelf. We've had it made for us. These are the custom ports. So we have just 1 tab, not 2, and we've had them made so this hole and these tabs allow it to pass cleanly through the port, otherwise it's too tight. And then the fact that this isn't even glued in, the reason it doesn't move is because if you insert the USB, it's pushing against the AA battery. So when you pull out, you'll see the port will probably pull forward a bit. Look, you've got a little bit of movement, but it's all designed that this is perfectly fine. And as you pull out, you can either just push that back in or it's just what it is. But when you push in, it's firmly against the battery. So you get a nice, solid connection. It doesn't feel like it's moving around like it is, that little bit of play. But that play is needed in order to actually physically be able to install this. So the design is all based on very specific positioning and install. And looking at that, I haven't even checked as well. We plug in. Yeah, so there's the charge light. So see the red one on the inner side and the green one, similar to the other one. The red one's while it's charging, and it's charging at 0.5 amp, which is good. We might have to lower the speed of charge because this is a very thin board. The green light's also a bit bright, but that's working. So that's ideal. Who's the bot telling off now? Well, you also sell mod kits for the Famicom AV. We do and we don't. We have the Lava RGB, but the problem with the NES RGB is the physical port, the SNES port, and the fact it only works on normally NTSC, not PAL. Tim Worthington's mod is never in stock, and we haven't made one ourselves, so it just isn't listed at the minute. So let's just thermal this, turn that off, and see what the thermals are like. Yeah, Rusty's buggered off. I thought he'd be in his bed. So this is charging at the 0.5 amp. We could also take the lid off and make sure it is charging, which we'll probably do, but let's just see what the thermals are getting up to. Hopefully nothing crazy. Bear in mind as well, point temperature thermals are not that much of a concern, but this chip is in between the two batteries perfectly as well, so it won't make surface contact. But we don't want it running hot. We'll just slow the charge speed down until we get probably 40 to 50 degrees at most. And that'll just be, like I say, on the point of the chip. It won't be applying, you know, the temperature to the batteries, because I designed it so that this chip sits in the curve of the two batteries. So if you've got two batteries like this, and you can see where they sit, you see that chip? It sits right in between the curve of the two. So when this is flat on, you'll see, you know, the chip doesn't touch. So see the chip there? It's not making contact. So it's not going to actually touch batteries, which is obviously the safety concern. But let's see what it's up to at. That's actually not bad at all, 45. So there's nothing wrong with that temperature at all. That's a perfectly fine temperature, so that seems to be all working. Let's just do one more check that it is charging, which we can remove the cover, and you can see it stays in place when you remove it, so it's ideal. If we get the multimeter again and zoom out a little bit, there we go, and then we will check the voltage like that, so you can see it's 2.6790 and slowly dropping because it's just come off charge. But if we plug the charger in and then we measure, we should see this voltage slowly climb. So there you can see it climbing quite quickly. So 2735, 2736, 2737. So you can monitor the actual chargers working. For the mod, yeah, if you just reach out to us, just drop us a message, and we can always discuss doing one for you. I think we've already got one coming in. It's just that you might wait a little while because it's just we're busy, and it'll be me that has to do that mod. 50 degrees, no, it won't discolor the board at 50. I can touch on with my finger. It's not actual 50 in the sense of that'd be burning if it was 50. It's the point of the IC will be 50. But no, the Game Gear CleanJuice charge at like 90 degrees Celsius on the CleanJuice board, and they've never discolored. We've used them for years now. So that's a success. That's really cool. I'll get that into, well, I'll do a little bit more testing first to make sure that when the batteries are flat, this still works on like fully modded systems, stuff like that, like a maxed out console. But that's a good first test. I'm impressed with that. I'll come back to testing this later on this afternoon, maybe, the Pico Power. And these I'll probably do an install video on. So the only thing left before I can get back to doing the orders I need to be doing before I get shouted at for disappearing to do a live. I'd only popped up to get some Game Gear re-PCBs, and I've jumped on live to test these out, so I'll be in trouble if I'm not quick. What we need to do is connect these up first with power. So I've got bench set to 20 volts in, or considering we only need to test a little bit of load, we can plug in the USB, and I'll just use a 30 watt. We'll just test each rail individually. I don't need to test. We've got a USB down here. Just grab a USB. I don't need to test all of it fully under load, like 10 amps on each channel, because I've already done that on a previous design, and this is basically the Dreamcast design, so I know that's fine. I just need to test each channel one at a time to make sure the voltage doesn't drop, because that's what the previous build was doing due to the fake chips. So we can make our lives a little bit simpler. We have the power on test is there, so that turns the power on and off. These lights are always on at the minute, this USB one, just because that's more of a debug light and you kind of need to know the power's coming in. And then this one turns on whether the rest are on. So when you turn that on, the 5-volt logic is there present, which it needs to be because it controls these, and the power on turns the rest on. So that seems to be visually working, but it did before. We need to really get the scope out on this and make sure the voltages are stable. So let's just get the multimeter on first and make sure the basics are working. So we have ground here. Wants to rock around. This should be, that's 9 volts, so I presume the 9 volt switch is on, which is there. Yeah, it's on 9. Flicking that should go to 12. And sometimes when you flick this, you can't just dynamically change the voltage. You have to turn on and off. Oh, I'm missing ground. There you go. So we've got 12 volts on that. Let's get it into focus a bit there. So we've got 12 volts on. Flick it to 9. Yeah, it has dropped. This one will be 5 or 3, so it's 5. Flick this switch over. Actually, that should have been 3. I think I've been measuring the actual 5. Oh, yes, that's the permanent 5 volt. That's the permanent, and then... Oh, sorry. That one's the permanent 5. This one is the one that should change. So we flick that back, and that should drop to 3.3. There we go, 3.25. So just need to improve the tolerance of the resistors on mass production. So generally, it's working. Now we just need to test under load that still works, because that's another problem, that these will work under no load, and then as soon as you load them down, you're going to have problems. So I'll use... what can I use? I'll probably use this just so you can actually see stuff. This is crazy overkill board. This is where we can load it up with hundreds of amps if we need to, like crazy overpowered. But we only need to load one channel for now. It has a nice screen on so you can see. Prototypes of, we've got GBA, a new one. So this is a AA rechargeable CleanJuice now. So you've got AAs inside there, and you can recharge them with USB-C. That's working good. I just got to put it through a bit more test, but that now fully works, fits in, can charge. We just need to fix the brightness of the lights. It's a bit bright on the green and the red's dull. Then we've got the Sega Saturn Clean Power. So this is a USB-C power board for the Sega Saturn. We've got 3 different versions because the factory, the last one they sent, there was fake chips on, so these didn't work good. We have custom USB ports we've had made, which are basically the same as installed in that GBA. And then we've got this Pico, you won't even see it on here zoomed out at the minute, but a little Pico power board, so this big, that just generates a 5 volt rail at 3 amps off really low voltages down to like 1.2 volts, I think. So we'll test a load of these probably later today or tomorrow. But for now, the last one I just need to test is that this Sega Saturn Clean Power actually functions well. Now these, because of how these work, they are permanently on and permanently running. So these will run warm. These will run like 80, 90 degrees sitting there doing nothing. And the idea is it's because they're permanently charged and ready to allow up to 10 amps power. So this board, like sitting here now, is quite warm, doing nothing. But that is how this board works. It literally sits and runs warm, doing nothing. So we're not concerned about the temp, because we might be concerned about the temp if it's too hot though. Or did I just touch the inductor? Yeah, it's a bit toasty, that one. We'll do the thermals after. but it will run warm. That's like the point I'm trying to make. It's not a board that sits and runs cool until you load it down. It basically, if you're pulling no power or you're pulling 10 amps, this board will be the exact same temperature. It won't change temperature under load. It's basically permanently keeping the inductors saturated. So if we plug that in, have power. I probably should have soldered these on before applying power. We've got the shared ground. So let me just unplug that. And let's just solder ground onto here so we can load down this board. And then we'll just tap on each rail to load down the voltages. Right, so plug that back in. Get the thing actually plugged in. There we go. USB. Yeah, that's to load this up. So let's use this middle one, say. So we've got the middle one here. We don't need to load 3 amps. We need to load like 1.5 is fine. And it'll handle 7, 8 amps, but that's not what we're here to test for now. I don't have the power supply powerful enough setup. This is just a 30 watt. So we'll run this at just the 1.5 amps because I can do full load tests later. This is just to make sure it works good enough for the actual Sega Saturn. Yeah, our factories are in China, Shenzhen, but it's factories we've worked with for 16, 17 years now. And ones we trust. It's just the supply chain of the samples. They said, obviously, to make samples quickly, they try and source chips wherever they can. Mass production, they buy off DigiKey or, the actual factories direct. So the samples that we got the last time, they literally said, when I said there's a problem with the board, they told me, yeah, these chips are sourced from a supplier that told them they were refurbished, genuine, and they obviously weren't. So it's no problem using China, so long as you know how to work with them and to make sure that when you need quality items, you get quality items. You just have to know how to work with them. So the 12 volt rail, or set to 9 at the minute, there's 8.8. If we now put a load on, you can see there now it's loading it down and it's still staying at the 8.8. So that's working and loading down, which is what you want to see. So that's good. You can leave that on and you can tap the other rail. So let's tap this one, which will be the 5 volt, load it down. 4.8, 4.9, so it's dropped 0.1 volt, but that'll be volts dropped through this cable, not necessarily at source. So that one's working. So it's looking good so far. The 3.3, you can see this is measuring 3.2. That'll just be, again, we'll need a slightly better value resistor on mass production. And that's lost like 0.1 volts drop through the cable. So if we measured with a multimeter here, you probably got no volts drop at all, but going through this cable to here, you see volts drop. So that's all working. So we're happy with the design. My only concern now is, this is why we have 3 made as well. We've got 3 different inductors on, you'll see. So we've got this inductor, this inductor, this inductor. They'll generate different heat. So this won't matter too much. We'll still load it down, but it shouldn't matter too much for the heat. But let's see what this is running at, because I've got a feeling this one's running too hot. Like, it, based on wearing a touch there, that was quite hot. And I know they do run, yeah, so you see you got 1 channel there. So if we go to the side view, you can see just that rail, and it's running stonking hot, like 100C. So something's wrong. Either this hand-assembled one's got something wrong there, which it probably is at that. Even though it's fully working, the other 2 are sitting there at 80, which is about right. But that one's definitely a problem. So let's move on to testing the other. What are the test machines? These are just electronic loads, so we can basically load down these boards as if they're drawing power. So what we're testing is that these boards work under load and that they don't collapse voltage, which is an issue we had on the last samples. So they're called electronic loads, basically. I've just glued 3 together and cut the backs and made a custom USB cable just so it's easy to power 3 units in one go. So we could load down all 3 rails with heavy current if we wanted. And the board works. So I don't need to test really the function of the board on each one because it's literally identical. It's just it's got a different inductor on each. But we do care about now the difference in the temperature of each version. So where's my finger? There's my finger. So see, this one's getting hot as well. So the 12. Now I know the 12 volt rail does get hotter because it's obviously 12 volts. It's just the way this works. Oh, you can't see the screen. The way this works is it does get warmer, but those are much cooler 50s. This one, let's see where it stops at. Let's just zoom in a little bit on that as well. So you can see this one just keeps climbing. And I think on the Dreamcast, like I say, this sits at 80 anyway. And it looks like it's almost, let's move it back a bit so the camera can actually focus. Of course, now it's too high. 89, so not far off. That'll probably creep up another 5 degrees over time, but that's still a bit too warm, so I think we need to work on that. So now let's try, I don't know why I put the ground wire on, we didn't need that. Let's try the third one. And if it's still warm, we can tweak, you can tweak the frequency of the way the chips work. There's resistors on that you can set up the frequency for. So we might have to tweak the 12 volt slightly to improve it, or we might just have to find the right inductor. So those 2 rails aren't a problem. Clearly the 3 and the 5 volt aren't a problem. It's mainly this 12 volt. These, no, if you turn the plug off, I've got a test switch on. If you turned the console off, then it would turn off like that. And then these will just obviously drop back down now and cool down. So these are now not on, this is just cooling down. Also, the final boards have thermals on the back of these. That's why they have thermals. It's just the way these chips are designed is to literally sit fully loaded so you get no volts drop. It's all about having a ridiculously smooth power rail. So these will have like 10 millivolts of ripple on under 10 amp load. So they are designed to be, same way the GPUs in the Xbox Series X work, they use a very similar layout to this. You'll see these kind of same inductors in the Series X. They sit there running, when they're turned on, they're basically running at max power all the time. But because the main's powered, that doesn't matter. They're just sitting there with the inductors full of energy, ready to be consumed. But they're working under load. This one seems the best so far. This seems, let's just give it a little bit. So that's going up. And like I say, it'll happily sit. If we get a heatsink, let me see if I've got a heatsink. You'll see the difference in the heatsink. It's just going to be, that's the point as well. Is it the chip or the inductor? It's the inductor. So the inductor's sitting with current, and you can see it's going to top out at the operating limit. So this is why they come with, if I can find any that actually do. So Dreamcast. Right, so here's a Dreamcast Clean Power. They come with these big heat sinks on the back for that reason. So if we can, and you can see it's exactly the same design. So you can see we've got, this is a proven tested design. I've done a video on it under load, and with this on, they stay cooler. So let's see if I can pry this off. I'll probably destroy this board getting this this heatsink off, but let's see if I can. What can I do without cutting my finger off? Let's try and cut through the adhesive. Where's a pry tool? There we go. Oh, stuck back now. Haha, there we go. So now, if we look at this temp, where are we at? See, that's maxing out at the 120, so that'll just now throttle. That's its limit, so it's designed to run up to 120. But that's obviously too hot for what we want to do. This will be a custom heatsink, made a different shape for the Saturn. But as soon as you put that heatsink on, let's see, that's now dropping slowly, so it's 116, 115, so we'll probably toggle the power off, let it cool down, turn it back on, and then see what it'd normally be like. Product design, I can normally knock out a circuit. If I've got the idea in my head and what I need to do with it, a few days I can design a circuit. It takes a few weeks to get samples, and then that all depends whether your first design just works or doesn't work. And you can have iterations for weeks or months, or you could have it where your very first design works, and then mass production takes 4 to 6 weeks normally on average. So even if I have a design, say I know a design I want to do today, I design it today, gate and production, you're still talking 6 weeks realistically at the bare minimum. Factory makes samples in a week, sends it to us, takes another week, that's 2 weeks. I confirm on the day it works. They start mass production, that's another 4 weeks, and then shipping another week. So probably 2 months is a realistic kind of start to finish design, unless it's a very simple design. So now that's had a chance to cool down. Let's see what the heatsink does. And we've also got, I think these sample boards are 1 ounce copper weight, and the final productions are 3 ounce, so 3 times the thickness of copper plating, which all helps with heat dissipation. You can see that slowed it down quite a bit. This would already be at like 70, 80. So I think the design's working. There's no issue with the design. It's just I'd like to see this 12-volt rail a little bit lower if we can. And that could be, we could limit the current as well. This is probably set up to, like I say, handle way more current than it needs, because this is the rail for like the DVD drive, the CD drive rather. Yeah, that's slowed down quite a bit. So 60, 70 is a lot more acceptable now. And it's almost at its limit. It's very slow in increasing now. So you normally find when it starts balancing like this, you're going to go up about 5 degrees more. Once it's kind of struggling to get a degree up, it's finding its thermal balance. So that's all working. And then, like I say, these ones you can touch just about, the inductors. This one, 70 is going to start burning you, so I want to try and get that temp down a bit. And all I'll do for that, I think I've already done it before and played with it, but you can change the frequency that this runs at, and you want to find an ideal frequency that keeps the inductor loaded at the right resonance, in a sense, to get the least amount of heat. So I might do that later. We might play with the resistor, but that's working. Like functional wise, the thing I wanted to test, there's no issues with this board. The heatsink is not taking that much heat away because it's the inductor. So this would probably benefit with, I'll tell you what, let's put a little heatsink on top of that inductor instead. It's not really passing through the board much. So let's just, did that camera just literally almost track me all the way around the room? Right, so we've got a baby heatsink there. Or we could, what about if we, yeah, factories. You can start on Alibaba. You will find factories. It's just like our battery factory is on Alibaba, but we work with them direct with WeChat and email. So it's just finding factories you can trust, basically. And some you'll find are way cheaper than others. Some will only give shit products. Others will work with the highest end products. So the factories we use are like they work with major retailers, Microsoft, things like that. So we know that they are, let's take that heatsink off the bottom, they are good factories. So this might be a solution as well, because it's just inductors needing to dissipate heat. So that's on all three. Let's see what that does to the heat. It's not actually the circuit board, it's just the inductor sitting primed that's taking the time. And this is, again, if you look at like the Xboxes, this is why the Xboxes have the metal heat sinks and little thermal pads on inductors, because it's not an issue with the design. It's that the design is trying to handle a lot of current, so you have to get rid of the heat, basically. And look at that. So we have 37. What do we have inside? Direct touch on the inductor. Where are we? There. So there's the inductor at 63, even inside. So the hottest point of the inductor is 63, but the heatsink is still in the 40s. So the heatsink's nice and cool. So let's just give that a minute, let it get up to temp, and see how it fares. I think that's a nice option, actually, just getting a custom heatsink made that sits on the inductors more so than the thermals on here will be if the IC gets warm. So we could always double up. We can have a heatsink on the bottom and a heatsink on the top. There's no issue with that. Running it, the cooler it runs, the better, basically. We don't need this USB load now. We've tested that. That we could put on the bottom, but like I say, we don't really need it for this test. And now, let's see where we're at with thermals. Finger there. Yeah, that's staying pretty cool. So 30, and the inductor inside is 70. So it's not really taking away the heat massively, to be honest. So the inductor coil is always going to be warm, but that's not really done much. Even though the heat has got to be, because the heat sink's warmer, so it's helping. But I think that's just something I'll play with. So we might play with this later. Have a look, see if we can get that temp down. The other ones are perfectly fine. The others are sitting like 50. That's where I want to see this one, ideally, if we can get it doing that. But I think the fact that because the voltage is higher and it's spec'd to handle current, the higher the voltage, then you need to store, current times voltage is wattage. So this has got way more wattage passing through it. So it might just be that 12-volt rail has to sit fairly high. But I don't think see that heatsink's working because it's taking away the heat. That's getting like warm now. But yeah, I don't like quite how warm it's getting. I think I could do with improving that. Yeah, the bottom of the board, so maybe top and bottom. But the main thing that helps this, and it's the problem we can't really test with on this board, is the production. Where's the? Don't know where the board's gone. The Dreamcast board. There. So this production board, it's the exact same design. This is 3 ounce copper, so this runs a lot cooler. Because the copper on here is so much thicker, so it naturally pulls away heat from the inductor better than a heatsink will. So we might have to just get samples made in 3 ounce, so we know this is fine. Yeah, that's not getting any hotter now. I think it's just, I reckon that's at 55 degrees based on how it feels on my hand. Let's just have a look. There's no way that's 30. It's going to be reflective with it being aluminium. Yeah, there's no way that's... I can tell by feel that isn't 30, but metal reflects heat, so it's hard to see heat on a heat sink because it just reflects light, and obviously infrared reflects as well. But the inductor there, 79 is perfectly fine on an inductor. That's settled in for a while. That's acceptable, but yeah, they're all sitting. Oh, that's like going up to 89. Yeah, I'm not happy with that, really. I think I need a little bit of work on trying to get that down. So I won't send this one out. We will work on this in a little while. So that'll be the goal for later. I just need to crack on with orders now. But we'll try and get the temps down on this 12-volt rail. These are, like I say, acceptable. They are. You can touch them. They're not that warm. But that is too hot for my liking on this board. Although, like I say, because this design is the exact same design, like literally the exact same design, we shouldn't have any issues if we use 3-ounce copper, because that's all we've done here. We've just put 3-ounce copper on, and this keeps it down to like 70 degrees permanent. And these are down to like 30, 40, but we'll still play with it later. And then we'll look at, we might as well look at maybe that Pico. We'll do a test on that Pico as well, do a thermal load on that. So I'll just get back to some orders now, and then I'll probably jump on in a little while. So thanks for joining in for a nice quick stream anyway. I guess it was still an hour, but everything seems to be working. We've got the new product here we can probably release. And this works, it's just we need to try and get that temp down. That's too hot. So I'll catch you guys maybe later today.